Okay, so number one, hopefully we can see the need for product rule here. That 3x, that negative 3x is one term. The secant of 5 minus pi x 9 is the second term. Recording. Okay, f prime g plus f g prime. Okay, secant's derivative is secant u tangent u times u prime. And now u prime is the derivative of what you see inside the parentheses. The 5 goes to 0. Remember, pi is just a number. There's no need for product rule here. That's just going to hang out in front as we find the derivative of x to the 9th power. So we bring the 9 down and we subtract 1 from the exponent. So negative 9 pi x to the 8th. The only thing I'm going to ask you to do in terms of cleanup is just try to pull all the non-trig related terms out in front. So this one is already in front. We're going to pull these two terms. These are all connected. We'll pull these together out in front. So the negative 3x and the negative 9 pi x cubed becomes positive 27 pi x to the 9th. So those get pulled out in front. Okay. Any questions with number one? Okay, everybody okay? All right, number two. Hopefully we can spot the need for quotient rule here. You got the numerator and denominator. Okay, f prime g minus f g prime all over g squared. Okay, so cotangent becomes negative cosecant squared u times u prime. And the derivative of pi x to the fifth, we just go through power rule. That pi just hangs out in front. Back down to the g function, no changes. Okay, G prime cosecant becomes negative cosecant U cotangent U times U prime. U prime, E is just a coefficient, just like pi is a coefficient from the x. So the derivative of 3x is 3, so the derivative of EX is just E. All over denominator squared. Make sure that we square both the cosecant and the 6. Now, all that's left to do is we're trying to pull the non-trig related terms out in front. So the negative 11 and the 5, pi x to the 4th, and the 6. I'm going to just pull all that out in front. Now, I know I'm not going to give you a calculator, so you can just pull all that in front. You don't have to spend the time to multiply that. You can just say negative 11 times 5 pi times 6, but it ends up being negative 330. And over here, the negative 11, the negative 6, and the e can be pulled out in front as 66e. And here in the denominator, both the 6 and the cosecant are squared, so that's how I got 36 cosecant squared EX. All right, questions with 2. All right. Yeah.
For the G prime, why would it be cotangent for what all of it for G?
The derivative is cosecant cotangent. This I brought this down because of the f. Okay. Okay. Anything else? Everybody okay? All right. Number 3. All right, so hopefully we can see the need for chain rule here. You got all this mess, that 11th power and the cube root. We're gonna try to bring all that out instead of parentheses. Now this 7, it feels like we ought to maybe go through quotient rule, but we don't have to because that's just a number. Let's just pull this out in front. This 7 can come out as what? 1/7, right? So it's just a coefficient. It just happens to sit here in the denominator, but it's just really a coefficient. So this is how we can write it. Pull that as just a number that sits out in front, makes it a little bit easier to work with. And then let's work the bracket here. So this, you got the cube root, you got that 11th power. You can merge that together as just one rational exponent raised to the 11/3. A lot easier to see the need for chain rule having it written out this form. Right, it's a lot easier now, right? It's a lot cleaner. You can see the outside portion a lot easier. You can see the inside portion a lot easier, and also the need for chain rule. Okay, so we're just taking turns with each derivative of our portions here. Okay, so starting with the outside portion, we go through power rule. The negative 1/7 times we bring the 11/3 down. We subtract 1 from the exponent. We keep the inside the same. And once we do power rule for the outside, then in a separate space, we'll do the inside's derivative in its own space outside of that first term. Okay. 11/3 minus 3/3, it's 8/3. Now ready for cosecant's derivative. So that's going to go in this space here. Cosecant of u becomes negative cosecant u cotangent u times u prime. Now u prime, we have to think about the derivative of what we see inside the parentheses. Now e is just a number, so 3e squared doesn't become 6e, right? We don't treat e like x, it's just some number. A number, a constant will just go to 0, so this all goes away. The pi squared x, though, has a variable in it, so we got to do power rule here. Pi squared x becomes just negative pi squared, right? Imagine that's just a number, right? Degree 1 will just become a constant. Okay. Now, as far as the cleanup goes, we're just going to pull all the non-trig terms out in front. So we already have these in front. The negative we can pull in front. The negative pi squared we can pull in front. So the two negatives become positive. We get 11 pi squared over 21. And then we can just put all this after that. If you wanted to, you could merge these a little bit more and do 8/3 plus 3 over 3 becomes 11/3 and make it all together, but you don't have to. Only thing I'm going to ask you to do is pull the non-trig related terms of trying. You don't have to do GCF or reduce.
Negative pi squared.
Sure, yeah. So the derivative of, so imagine here, imagine this was just negative 9x, right? Negative 9x would just become negative 9. Negative pi squared x is the same thing. It's just some number hanging out in front. So negative pi squared x would just become negative pi squared.
The 3 squared cancels out.
Exactly, it goes away because this has no attachment to any variable. That's just some number. A number will just go away to go to 0. Yeah, any other questions with 3? All right, back page. All right, number 4, hopefully we see the need for implicit. You can see y's all over the place. We got to keep track of all of our dy dx's. And also product rule. You see product rule, that's going to show up twice here. Y cosecant y, these are two separate terms being multiplied together. X cotangent y, that's also two separate terms being multiplied together. Product rule will be applied twice. Okay, let's take care of our product rule for each of these terms separately. So y's derivative is 1. And we have to attach dy dx. We're just asking for y's derivative, so 1 dy dx. G function doesn't change. F doesn't change. Okay, G prime, we're asking for cosecant y's derivative. Cosecant u becomes negative cosecant u, cotangent u times u prime. That u prime will ask us for dy dx to show up again. All right, everybody okay so far with product rule for the first problem? Okay, now moving on to product rule for the second set here. X becomes 1. G function stays. Back to F. G prime, cotangent u becomes negative cosecant square u times u prime. Another dy dx will show up here. Okay, so that's the second product rule. Everybody okay there? All right, we keep going. Negative y, that's just a linear term there. Negative y becomes negative 1, but we're asking for y's derivative, so another dy dx will pop up. Oh, and by the way, if you count the number of y variables here, 1, 2, 3, 4, 5, there's should be 5 dy dx's that show up, right? So at the end, we'll count, make sure that there are 5 dy dx's. Okay. Negative y becomes negative 1 dy dx, or minus 1 dy dx. 9y squared becomes 18y. Again, y variable is going to produce a dy dx. So 18y, we find the derivative first, and then we attach dy dx. 3x becomes 3, or negative 3x becomes negative 3. What happens to 11 pi squared? Goes to 0, right? This doesn't become 22 pi. This is just a number. Goes to 0. Okay, so if we count here, we're expecting 5 dy dx's. So there's 1, 2, 3, 4, 5. All right. Any questions so far? So we're done with the calculus. Now it's just a matter of adding and subtracting. Yeah.
Reason you got a G prime for like a cotangent one.
Mm-hmm.
You just go over that process again.
Sure. So cotangent's derivative. Cotangent's derivative is negative cosecant squared u times u prime. So therefore, cotangent of y becomes negative cosecant squared y times y prime, and y prime is just dy dx.
Where did like the minus like 1 dy dx plus?
Oh, so right. So we're done with the product rule. Product rule is just for that green that I have here, and then the rest are all just power rule.
So you did 2 rows at once.
Yeah, right. So I did product rule here, and I just continued through and finished the derivative for each of the separate terms here.
Okay.
Yeah. All right, any other questions before we do our cleanup stage? Okay, so in terms of cleanup, I'm just kind of pushing these terms together. I basically want the non-dy dx terms on the right side and the dy dx terms on the left. So let me highlight all the dy dx terms that I want to collect on the left side. So I have one dy dx term here, another dy dx term here. There's a dy dx term here, one here, another one here. Right, so I have 5 dy dx terms that I want to collect on the left side, and the other side will be the non-dy dx terms. Okay, so after I move all of them over to the left side here, I get This is a negative term here, so I'm going to add that over, change the sign, move it over to the other side. So this is going to turn into a positive x cosecant squared y dy dx. This -1 dy dx is sitting on the right side. I want to move it to the left side, so I got to change the sign. So +1 dy dx. This term is sitting on the right side with the dy dx. I would like to move it on the left, so I got to change that sign, -18y dy dx. These two terms that do not have dy dx, they're already sitting on the right side, so there's no need to change the sign. I'll keep these terms the way that they look. Okay, so now all these have a dy dx I can factor out. Now divide all this over. Okay, questions with 4. Okay, number 5. Sorry for the couple of mistakes, but I sent out the corrections on Teams, but let me go through it step by step here. Sorry, I sent the corrections through Remind. Okay, so position is given as 7 cotangent 5x. Find acceleration. So acceleration is the second derivative. We have to get down to velocity first, and from velocity, we can get down to acceleration. So cotangent u becomes negative cosecant squared u times u prime. It's our velocity function. Do some cleanup here. We can merge the 7 and 5 together. Okay, so we're halfway there. To get to acceleration, we have to find the derivative again, but notice that squared there, that is not in the best form for us to identify the derivative rule. So we're going to pull that 2 outside a set of brackets. Help us see the need for chain rule a bit better. Okay, chain rule needed here. All right, we take turns with each portion to build the derivative. -35 bracket square, we go through power rule. That becomes -70 bracket to the first power. So we're done with the outside portion's derivative. Now ready for the inside. Cosecant u becomes negative cosecant u, cotangent u times u prime. Okay, let me do some cleanup here. I'll pull everything non-trig related in front. So -70, the -1, the 5. Merge all that together. I get a positive 350 in front. Going to merge these cosecants together here. That's part A.
It's further on your entry key.
Right. So I made a mistake on my key. So the correction is made here. So when I did the on the answer key, when I did the power rule, I brought the 2 down, but I forgot to subtract 1 from the exponent. And but these two end up merging together and the square shows up again here. Okay. And I also messed up on part B on the key. Okay, so that's part A. Any other questions with part A? Okay, part B, find the acceleration at t equals pi over 6. Now we're just inserting pi over 6 in for x, and we're just trying to use our unit circle values to get it down to a numeric answer. Okay. So we insert pi over 6 in for x. 5 times pi over 6 becomes 5 pi over 6. Same thing here. 5 times pi over 6 is 5 pi over 6. Okay, let's think about our unit circle values here. At 5 pi over 6, we know 5 pi over 6 is going to be in that pi over 6 family. In that second quadrant. Pi over 6 family is going to have a √3/2 as the x and the 1/2 for the y. This is second quadrant here, so we're going left and up. Left is going to cause that x value to be negative, and up is a positive 1/2. Okay. You know that your x value is your cosine, your y value is your sine. So cosecant is related to sine. Cosecant is the reciprocal of sine. So we know sine of 5 pi over 6 is 1/2. So cosecant of 5 pi over 6 is going to be 2/1. Cotangent of 5 pi over 6, we know cotangent is x over y, or cosine over sine. So it'll just be -√3/2 divided by 1/2. Now, if I'm dividing multiple fractions here, the nice thing is that these both have 2 in the denominator. I can just wipe the 2's out and just divide the numerator. So -√3 divided by 1, so just -√3. Now, if you're left your answer like this, because this is such a large number, you want to multiply it out, that's fine. But you just have to get it down to this stage. Okay. But we're going to multiply this out here. We get -1400 over 3. This is my acceleration. But you cannot leave your answer in this form. You got to go down. You got to use your unit circle values to get down to this stage. I don't mind if you don't clean this up, but I need to see from here to here.
You got like -√3. Just cancel it out.
Yeah, just cancel out the 2's. And then, because I know the 2's will just cancel each other out. So it's just, I can just divide the numerator. So -√3 divided by 1, which is cosine over sine, which is x over y, which is cotangent. All right, number 6. Find the tangent line equation. So we have to find order pair. We have to find slope from the derivative and then point slope form. Let's get the derivative out of the way here. But first, we see the need for rewriting, right? That 3 is kind of making it difficult for us to see that full chain rule impact. So let's rewrite it. Okay, so we see the need for chain rule. Identify the outside and inside portions. Take turns with each derivative. 2 bracket cube becomes 6 bracket squared. Don't change that cosecant 7x. We're not ready for it yet. Okay, so now we can move on to the inside portion. Cosecant u becomes negative cosecant u cotangent u times u prime. Okay, let me clean this up here. Pull all the non-trig related terms out in front. The 6, the -1, the 7 can go out in front as -42. Merge the 2 cosecants together. I can make it cosecant cubed. Okay, so now that we have our derivative, we can use that pi over 6 in the function to get our y value, our order pair. We can also plug pi over 6 into the derivative to get our slope. So if I multiply 7 in for, or pi over 6 in for x, I get 7 pi over 6. Okay, if we think about 7 pi over 6, we know it's going to be in that pi over 6 family, just like how we saw above. It's just the signs are different, right? Third quadrant, 7 pi over 6, so both the x and y are negative. Okay, so cosecant of 7 pi over 6. Messed up again, didn't I? I did the sign. Okay, so on the key, let me change that around here. So cosecant is the reciprocal of sine. Cosecant of 7 pi over 6. So cosecant, we know that sine is -1/2, right? And then if I flip that around, I get -2. Cotangent is x over y. So again, I can cover up the 2's. I know they'll cancel out. So -√3 over -1, so just √3. Okay, there's my slope. Next up, order pair. So I have to plug 7 pi over 6 in for x. Okay, we know sine of. Sorry, this is negative. Yeah, negative times negative is positive. Okay. We know that cosecant is related to sine. We know sine of 7 × 6 is -1/2, which means that cosecant is going to be flipped, which is -2. -8 times 2 is -16. Okay, we have our slope, we have our order pair, and now we can do a point slope form. Okay, is that what you guys got as well? Yeah, I messed up with 5 and 6, treating cosecant like sine, and I did not flip that 1/2. Yeah. Oh, yeah, you're right. 5 or 6. The 7 is within the function here. Yeah. Okay, let me come around, see if you guys have any individual questions for me.
Are you gonna keep those up on the board?
No, we gotta memorize them. Yeah, we gotta memorize your unit circle values.
They're gonna be placed on the quiz where you can write your own.
Yes, I'll have a space for your rules, but if you need additional space to do unit circle values, I'll give you another scratch. You have to be personal.
It's mostly in person.
Why would you go in first if it's all?
It's really past well.
You don't even need about.
I would only do it, and also there's some friend, but they're taking people.
Are you gonna do it? What do you do? Like just read a book?
No, it's an art fund.
Yes.
We get a bunch of art workshops, and then just stay overnight. Really,
For National English Honor Society.
the National Art Congress.
Oh, I thought you said EHS. Oh, I was like, yeah, literally. I was like, why you would say I just look, circle 20 minutes before my quiz.
That's so real.
Yeah, sorry.
Let's do the finger thing.
What's the finger thing?
Like, have it at 5 or 6. I feel like I'm there. I really, it's kind of you with really, no, it's just like plug.
Wait, okay, so you have it at 5 or 6. It's gonna be root 3 over 2.
Okay, you have like 5 or 6, finger down.
Finger down, root 3,
And then 1 hand.
And that's all for that.
and then
You're on
Wait, we go.
5 over 4.
2 over 2.
Yeah.
Oh, okay, and then if you put.
You're setting the national market plus equals to negative.
1/2, and then over 2.
Where does that work?
That's I already had a short set. Yeah.
Wait, but how does that?
So then
How is that?
and then root 3.
I like that. Okay, okay. Let me see. Let me do it. Let me
Like a lot of stuff is clear for me once I memorize
put it up. This is root 3/2, 1/2. This one down. That's 2 root 2.
You can just like,
So 2.
this
one down, 1/2.
Yes, yeah, you should have enough space, but not.
Yeah.
Yeah, I like that.
Like, what we need to ask, like.
I think cosine is x and then sine's
Or
1.
that's current, like the side.
This is just to help you remember,
Alright.
what the second, third, and fourth quadrant looks like in terms of these order.
Okay. Oh, yeah.
I remember when we used Latimer's that time. So fun.
That was fun. Like, that means like top right's like all of them are positive and
Yeah.
top left is only a sign.
Only the sine and cosecant